Let's go ahead and do revision of the quadratic function. Write the quadratic function in standard form, draw the graph of the function, and state the significant characteristics. Let's start with number 1. So here they're specifically telling us to do standard form. Okay, so 2y minus x squared plus 4 equals 0. We're going to go ahead and do standard form. 2 is attached to it, x squared and 4. We're going to remove those two first, so we can say, okay, minus x squared becomes plus x squared on both sides, and plus 4 becomes minus 4 on both sides. That's beautiful. So we have 2y equals x squared minus 4. Now let's get rid of that y, of the 2 in front of the y. So we're going to say divide by 2 on both sides. So y is equal to, technically, 1 divided by 2 x squared minus 4 divided by 2, which we can simplify to 2 minus 2. That is our standard form equation. Now, standard form is y equals ax squared plus bx plus c. And in this instance, you can now identify that a is equal to a half and c is equal to negative 2. What about b? b equals 0, because 0 times x is 0, and if it was 0, we don't write anything down. First part of the question is done. We've got standard form. Let's do the second one. We're going to sketch the graph. Now, to sketch the graph, y equals a half x squared minus 2. Y equals a half x squared minus 2. This is not a linear graph, so I cannot start with, I can start with my y-intercept, right? So that's brilliant. I can actually say, okay, there's my y-intercept at the point negative 2. But now I can't do a straight line graph. I don't have a gradient. Instead, what I'm going to do is I'm going to identify my x-intercepts. So to do this, I'm going to say x-intercept means y equals 0. 0 equals a half x squared minus 2. If I take the 2 over, means that 2 equals a half x squared. And I multiply. So over here, what did we do? We said plus 2. Now I want to get rid of the half. So I'm going to multiply by 2 on both sides. X squared is equal to 4. And now I'm going to get rid of the square. So I'm going to square root on both sides. And then x is equal to plus minus 2. Remember that because it is a power of 2, there must be 2 answers for the x-intercepts. Okay, so there are 2 of them. So let's input that, positive 2 and negative 2. Now I can go ahead and connect this, and this will be a parabola that looks more or less like that. And there you go. You have managed to sketch the graph. Now, what characteristics do you need to know of a quadratic function? Let's start with what we had initially, right? So if we're talking characteristics, I would start with my x-intercepts and my y-intercepts. The other thing, we don't have a gradient, right? But there are other characteristics. So let's say x-intercept, we calculated them as being, now if you're going to give me intercepts, please give them to me as coordinates. You can put a semicolon in between. So this is going to be negative 2, 0, because x-intercept y is 0, and positive 2, 0. What about the y-intercept? Y-intercept is in the equation. That is negative 2. So that one is going to be 0, negative 2. Beautiful. What else would I like to know about this graph? This graph has a turning point. There we go. That's a max. So a minimum point. We got a turning point. And our turning point is at 0, negative 2. What else can you tell me? What about the axis of symmetry? The axis of symmetry is the line that I can fold it on. So notice that this is 2 spaces away and that is 2 spaces away. So my axis of symmetry is going to be the line x equals 0. How do we calculate axis of symmetry? So this I took from the sketch, right? But there is an equation. If you wanted axis of symmetry, you would say axis of symmetry is equal to b divided by 2a. Sorry, it's negative b. Now let's substitute. We're going to use these values here. And we're going to say, okay, negative 0 divided by 2 times a half gives us 0. So your axis of symmetry is most definitely 0. What about domain and range? And range. Okay, let's do this. I'm going to do domain. Let's erase this. Let's do domain in... The question for domain is in terms of the x values, right? Which values are valid and which values will never exist? If I look at this graph, I have a turning point or a lowest point, and that is over here on this line. Okay. If I go above the line, my graph exists there. But if I go below this line, the graph never ever goes below that line. Over here, there is no graph. So this part is cut off. There is a lower boundary for this graph. And this is on my on my y line, on my top to bottom line, right? So what I'm going to say is that this graph exists from positive infinity going down, 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 and it ends at the point negative 2. Now negative 2 is included because I have a coordinate on negative 2. So what am I going to say? I'm going to say y is greater than and equal to, because it does touch negative 2. That means that all the numbers from negative 2 upwards are part of this function. And all the numbers below negative 2, like negative 3, negative 4, negative 5, will never show up on this graph. I'm not done with the range. I also need to input that y is an element of all real numbers, because everything in between, the decimals, etc., are all a part of that. Another way of writing this would be to say that you have negative 2, semicolon, positive infinity. So y can be an element of that. Those two are 2 ways of writing the exact same thing. Please notice that for domain, we write from the bottom upwards. So you start with your negative first and you end with your positive on the right. Negative on the left, positive on the right. Your x values will be all inclusive. There's no boundary there. There's no restriction. So this says that x is an element of all real numbers. They all are included over there. Okay, so those are all of your characteristics. Okay, so that is your quadratic function.